G'day there, you're watching the Aussie BIM Guru, and today we're going to be looking at creating a document transmittal using Dynamo in Autodesk Revit. So what is a doc trans or a document transmittal? Just in case you're not aware of what I'm talking about. Typically in architecture and also engineering, we use these forms to keep track of our drawings. It's a bit of an old school methodology. There's a lot of efficient ways you can do this now using online common data environments instead, but most companies I work at still seem to use a system a little bit like this to track all the drawings. So essentially it's got row items to represent each drawing number and name, and then revisions indicating when it's been issued by a date column. So if you use Aconex, it's worth being aware Aconex can make these for you. So there's actually a tool under the I think it's the transmit button. It's a bit hard to read that, sorry. And you can create a transmittal. That's how you actually send your drawings. But there's also an option with it embedded within Aconex where you can generate a list of drawings and the dates they've been sent on as well. Because essentially when you transmit these drawings, it's Aconex's way of understanding that you're up revisioning these drawings and sending them to people. But we use a more manual workflow in absence of this. So a typical workflow is that the drawings are prepared, a document transmittal is made or updated manually, and then it's sent along with the drawings. So there's a lot of issues with a workflow like this. Firstly, it's manual, so it wastes a lot of time. There's room for human error, and often people are just too busy to update these drawing transmittals as well, so they become inaccurate and unreliable very quickly. So we're going to use Dynamo to fix this problem. So essentially we're going to try and automate a document transmittal format out of our Revit model based on the revisions by sheet to get something that looks a little bit like this. So we're going to be using a few custom nodes today. Two of them are from a package called Bumblebee for Excel formatting, and one is from Archilab to collect all the revisions by sheet. And we're going to be using 2.0.3 today. I believe you'll probably need something in the version 2 point something in order to get Bumblebee to work with this. I think there's an older version that may work with Dynamo 1. Anyway, let's get started. Sorry, I jumped one too far there. So let's just jump straight into Dynamo. So in the background, I have a model where I've applied some revisions to sheets. So I've just taken the Autodesk sample model and I've generated a list of revisions with dates, names, who it's been issued to and who it's issued by. And I've also added these to certain sheets. You can see I've got one sheet that's not for issue, that has no revisions on it, so we want to exclude this from our transmittal. But all these other sheets have various revisions applied to them depending on when they were sent. So we need to find a way to turn this into a document transmittal format because Revit can't natively produce a document transmittal. If I create a sheet list, you'll note that I can only add revisions for the current revision. I can't add past revisions by column. There's no fields available to do that. So really important that we find a way to do this in Dynamo. So let's boot up Dynamo. And we're just going to start off by going to manual mode. And we'll just grab a string and we'll get a category by name. So we're going to get our sheets first because we need to find all the revisions applied to our sheets so that we can create a schedule for them. So we'll get sheets and we're going to get all elements of category. Most scripts in Dynamo start this way by collecting a whole bunch of elements, filtering them down and getting some data about them. Okay, so we should have all our sheets if we do this, and you'll see now we have 7 of our sheets. You may have more sheets in your model and that's okay. The script is built to handle any number of sheets. What we're going to do then is we're going to sort our sheets by their sheet number. Your sheets may be sorted in the right order, but you'll notice in this case they're not. My title sheet's right at the back of the set. I think this is the order that the drawings or sheets are created in that sorts them naturally. So their element ID, I believe, might be how they're sorted. Hard to tell, it looks like it. So that's not how we want to sort our sheets. So we need to sort by key. So because our sheet numbers are essentially numerical in this case, we can sort by them, or they have a numerical aspect to them, or an alphanumeric aspect. So we're going to feed those in as our keys and feed in our sheets. And essentially we should get these in an order, and these also get rearranged in the order of the keys, which are the sheet numbers. So now our sheets occur in order. From there we're going to use a node from Archilab. So this is where we're going to use our revisions by sheet node. So I might need to find this. No, there we go, that's it there. Cool, so this will actually give us sublists of all the revisions applied to sheets. So you'll see here we get a sublist for each sheet. Note that in this case one of my sheets has no revisions, so we want to filter this out. So we're going to just check if any of these lists are empty. So we're just going to determine if any of these lists are empty. And we'll get a false by default, we want to apply a longest lacing. So we're going to check every single list. And there you go. Now we see we get one per sublist per sheet. So you'll see that it's identified this sheet, my second sheet, where there's no revisions. So we're going to filter this out by using a filter by Boolean mask. So we'll take all of our sheets and we'll exclude any sheets that have no revision. So you'll see that now we will be able to continue with our out list as our sheets that have revisions. Okay, so the next thing we need to do is actually get the sheet revisions of those particular sheets. We could also apply a filter by Boolean mask. It's up to you what you prefer to avoid using a custom node twice maybe. And what we're going to do is we're going to use the unique element ID in order to find matches with our actual revisions in our projects. You could try to match the revisions, but I find it quite hard to match elements in Dynamo. So I usually prefer to match something that's text, because text is really easy to find a match for. So I'm just going to get the element ID of all those revisions, and you'll see that these are very unique strings. What we're actually going to do is take a little bit of a shortcut here. So I'm going to concatenate each of these sublists. So they'll just turn into one big string per sheet. You'll see, there we go, we get a nice big list for each sheet. So a big string of text, which Dynamo is really good at handling. What we're going to do then is have to figure out which revisions occur within this list. So we're going to get an element type node and collect all the revisions in our project. So we're going to get revisions as our element type and then all elements of type. And this is so we can identify which revisions do occur and which ones don't. So I believe that we'll need to get all elements of type. There we go. So we'll get a list with every revision in our project. There we go. So you can see these are the ones we have. But what we're going to do now is we're going to sort them by their sequence. So the order that they occur. So we're going to get a parameter value by name. And that value is going to be the revision sequence. Because again, these may not necessarily occur in sequence. So we'll get a string and I'll look for a revision sequence with uppercase for both letters. And there you go. You can see that at the moment our revisions are occurring within sequence. If the dates were out of order, maybe they wouldn't occur in sequence. So what we'll do then is we're just going to add another sort by key, just for future-proofing the script. So we'll sort our revisions by their sequence as their keys. In this case, the order won't change, but it's just in case. And there you go. We'll get the same list because our keys have been maintained in order, so rearranged the same way. Okay, so from there we need to get the element unique ID of those revisions because we're going to use this to find a match. So we'll get the unique ID and we'll also get the element name. So we'll get an existing element name node so that we have their ID and their name. So there's their name and there's their ID. So now we can identify whether these occur within each concatenated list of revision IDs. So this is a little bit of a shortcut. It's going to save a little bit of processing time, this method, rather than trying to hunt for every single revision in every single list. So from these strings, we're going to search for this little fragment of a revision unique ID, and we should get a list of booleans. So in this case, we're going to need to run a longest lacing as well, so that we check every single list for whether these occur. And there you can see which revisions occur and which ones don't in this case. So a really quick way of identifying that. Okay. So we're going to need to transpose this at the moment because what we're getting at the moment is we're getting a match as to whether this list of revisions contains each one of these. So this isn't by sheet, this is by revision currently. If we transpose this, we're going to go by sheet instead. So when we transpose this, for each revision, we should get whether it's matching the sheet's element IDs joined together. So now we can tell which revisions are present for which sheets. So if we go to the last one, for example, our last sheet, you can see that the last 4 revisions are true and the rest are false. So let's check this in our project. And there you go. You can see that it's true. It's identified that the last 4 revisions are true and the rest are false. So we've essentially identified a list of trues and falses per sheet for all revisions in the project. So this will help us build our document transmittal. From there, what we'll do is we will use an if function to replace these trues and falses with something more meaningful. So in our document transmittal, we'll use an X to represent when it's been issued and a blank when it hasn't. So we'll use the standard if node in this case. Usually I don't use the standard if node, but in this case I can, because my lists are going to be the same length that I'm feeding in my true and false outcomes. Typically, this won't work well if your lists are different sizes. It will always revert to the smallest list of the two. In this case, it's okay. So we're going to replace every true with an X and every false with an empty string. So if true, X, if false, empty string. And you'll see now we get a list of X's that represent when our sheets have been issued. So we can use this to create rows of data within our Excel document transmittal. So pretty cool. What I'm going to do also is figure out what the current revision should be, assuming all our revisions are numerical. Obviously, if you have alpha and numeric, it won't be so simple. In this case, I'm just going to keep it more simple. So I'm going to count the number of trues in each list, but I'm going to have to work at level 2. So if in each sublist, which is at level 2, how many trues do I have? And you'll see now I can identify the current revision by sheet. So I can see this sheet should be at revision 4, which it is. So if I go to this last sheet and I check the current revision, it is in fact 4. So we can see this is also correct. So that's great. What we need to do now is actually start putting this in a format that works. Whoops, I've opened a music program there. I'll just close that. This program is always very hard to close. There we go. Anyway, where was I? So we're going to create our data now for Excel. So we need to create a header row with sheet name, sheet number, current revision, and then the revision names after that. So we have our revision names back here. We also need a header row as well. So we're going to create a little list of strings using a code block. So I'll use a square bracket to start a list of strings. I'll use sheet number because that's my first column, so that's my first header. I'll do sheet name. I'll do current, and I'll add my revisions as a variable on the end. And I'll feed in this string, and I might just use enter just to make this a little bit more spatially economic. So if I run this, I'll get sheet number, sheet name, current, and then all my revisions in order of sequence. Obviously these isn't all at the same level, so I'll just flatten my output. But essentially, this gives us our header row for Excel. What we need to do now is organize this data into rows as well. So we're going to need to get the sheet name and the sheet number of each sheet, because these are the first two elements we need to place. Then we have our current revision and then all of our true or false outcomes for our revisions by sheet. So we're going to go back and get our sheets first from our out list. And note that this data will occur by column currently when we get it. So we'll need to process this into rows. Okay, but this should give us a list of our sheet names and our sheet numbers as columns. Then we have our our number for current revision, and then we have our row per sheet at the moment. So what we're going to do is we're going to take this output here and we're going to transpose it back so that it represents itself by column. So now we have all our data organized by column. So great, not including our headers, of course. So we need to join our data now. So we're going to create a list with 3 elements in it first. So we're going to have our first column, which is our sheet names. We'll do our sheet number first, then our sheet name, then our current revision. So this will give us 3 sublists or columns for Excel. And then we need to join this onto the front of our rows, our columns from our rows by revisions. So we're going to use a list join, and this will join them at the same level. So we're going to join all those onto the front of these. And now we have our data represented as columns, as it will occur in Excel, minus our header row. So we're just going to take our header row and just move this forward. And we're almost done at this point actually. So we're going to retranspose this data back now that we have it in the right order, so that it should be represented as rows now. So you can see it's number, name, current revision, and then each respective column of revisions. And we're going to add an item to the front. And as you can guess, we're going to add our header row to this list. So this should be all of our document transmittal data ready as rows. So we can proceed with this data now to create our Excel document transmittal. We're going to be using Bumblebee instead of Write Excel because Write Excel reformats all of the formatting of the Excel table that you write to. So we're going to actually build a template file. So I've went into Excel already and I've set up a template file. So I've turned all my text sideways in here using the rotate text up tool, and I've centered all my cells in my table and just given them a gray grid. So I've just done that by just selecting Control A and formatting all my cells and their positional formatting. So this is ready to be populated with data from Bumblebee. But what we need to do is actually copy this template as part of the script, because we don't want to update the template file, we just want to derive our Excel file from the template. So we're going to create a copy of this file, essentially. So what we're going to use for this is our copy file node. So we'll get a copy file node, which needs a file, a destination path, which includes the name of the file, and whether we want to overwrite the file. So first we're going to get our file template. So we're just going to get a file path browse node, and we're going to browse to that template that we're going to copy. We then need to get a file from path, because this expects a file, not a file path. So that's our template file that's going to be copied. We then need to set up a directory in order to tell the file where to be saved to. So in my case, I'm just going to direct it towards my document transmittal test folder. And these can all be Dynamo player inputs as well. So you can right click these and say is input, and let's call this template file, just in case someone has a template they want to use. We can call this one file destination. What we need to do now is use a code block. So I'm just going to freeze this copy file node because we need to tell the file its new name as part of its path. So we're going to make a formula. So we're going to say x plus y plus z. And these are basically going to be the components of the file path plus the file format, which is XLSX. We're an Excel spreadsheet. Okay, so the first thing we need is the file destination. We then need a string, and the string in this case is going to be a backslash. And as you can guess, the last thing we need is going to be the file name minus the extension. So this can be a Dynamo player input, and we'll just call this file name, no extension. And in this case, by default, let's just call it .trans. And we'll feed this in, and essentially this should build a destination path for us with a new name to that directory. So we'll feed that into our destination path. And then we just need a Boolean in order to tell the file whether it should overwrite the original or not. And we'll just set it to true because we pretty much always want it to overwrite. We're going to use this file in order to write Excel data to using Bumblebee, but we have to get this to wait because we can't write data to a file that hasn't been copied yet. So we're going to use a pass-through node in order to tell our data to wait. So we're going to make a pass-through node. So we're just going to use a square bracket pass-through wait for as an input list, and our output is going to be what we feed in the first index. So this is basically a syntax that tells data to wait. So I'm going to pass through my file's path, but I'm going to wait until my file has been copied. This is really important, otherwise it won't work. It'll occur out of sync and it won't know where to write to once it goes to create the file. So I'll unfreeze this at the end, but essentially this is the file that Bumblebee will write its data to. So in order to use Bumblebee, it's quite simple. So we need to get a Bumblebee data node. So I'll just do a search for BB data. And this is essentially where you input your data. Now the great thing about Bumblebee is you can create more than one set of data at once and write to multiple sheets in multiple files at the same time with one script. So it's really powerful. It's much more flexible than the Excel write function, and maintaining the formatting is great too. So we're just going to feed in all of those rows as our data into our Bumblebee node. And then we'll also feed in our sheet name, which is sheet 1 in a code block. And the origin in this case will be A1, but if you had header rows that you wanted to write separately, you could tell the data to start later, so you could add some extra rows at the top, such as project information. So we'll feed in our sheet name and our data origin. Keep in mind that's obviously the Excel column and row reference. Okay, so what we need to do now is use write Excel, but we're going to use the Bumblebee write Excel, which is this one here. So we're not using the export Excel. So we're going to feed in our Bumblebee data. If you're using more than one writing function of Bumblebee data, you can join them as a list and then feed the list into the Bumblebee data to write to one file with multiple Bumblebee data. So that's the power of Bumblebee. So our file path is actually what we're feeding through here. So it's this path that we're telling to wait until we've copied our file to that path. Then when we have, we'll write our Excel data to it. We use a little code block here just to say that we always want to run Bumblebee. And in this case, we are going to write by row. So I'll just take out those double apostrophes. So true, that will run it, but false, that will run by column. We're going by row. You could obviously transpose all your data and go by column, but there's no need in this case. Okay, so at this point, I can just unfreeze my copy file node, and I'm pretty much good to go. So I can just save this script, and I'll just refresh it by closing and opening it just to make sure all my inputs are true and correct. I'm going to navigate to my folder here, and I should be able to write my file as a doctrans. So if I run this script, it should create the data in Bumblebee in the copy of the file. So there you go, you can see my doctrans file there. If I open this, there you go. You'll see that it's written all my data by row, and I've got my sheet number, my sheet name, the current revision number, and each revision as a column, and each revision where relevant has been ticked with an X. So that's really powerful. You can imagine how much time I've just saved on a large project. And obviously you could format your data even more. You could separate it by series. You could find ways to replace these with numbers to represent the actual revision number, and you could add algorithms to deal with alphanumeric sequences as well. A lot more complicated. This is obviously a really simple document transmittal for small projects, and I think it does a really great job. And obviously this is runnable through Dynamo Player as well. So if I just close Dynamo and I boot up Dynamo Player, those inputs that we defined earlier will let us also direct some of the data. So I'll just boot up Dynamo Player. I'm going to navigate to this folder, so I'll just copy the path. Sometimes Dynamo Player takes a little while to boot up, but once you're in, off you go. Okay, here we go. So Dynamo Player should boot up. Great. I'm just going to navigate to that folder, and I'm just going to run my work in progress script. But before I do, I'll edit my inputs. So let's call the document transmittal something different in this case. Sometimes it can take a while to boot up that first script in Dynamo Player, but again, once you're in, you're in. Okay, so you can call a different location for your template file. I can set a different destination as well, and I can also change the name of my file. So let's just call this doctrans2, and I'll run my script, and it should write my document transmittal as doctrans2. It'll be the same file, but there you go, that's how quick it is. So really powerful, and it should save you a lot of time and add a feature to Revit that you might not have currently available via, say, things like plugins. So hopefully that helps people save a bit of time on their projects and keep track of all those drawings. So thanks for watching today. Hopefully that you found that helpful, and it gave you some ideas of how you can use Bumblebee as well. It's a great custom package. Highly recommend you look into it further. If you're not already following and subscribing, feel free to do so. I make videos twice a week at the moment, sometimes 3 times a week, and I'll be doing so for quite a while and covering lots of platforms. So thanks for watching today. If you've got any feedback, feel free to leave it down below, and hopefully I'll see you in the next video. Thanks. Take care. Bye.